Welcome back, everybody. So this will be the last session of Python course or Python training. So I will take you to the Visual Studio Code. So let's just open the Visual Studio. Yeah, by now I think you love VS Code, right? Don't you? I believe so. You may like this. So your specific folder is Python Winter 2021. So we call it a folder, a directory. Actually, also it's a project. So this is our project. So I open it. As you know, we have covered quite wide variety of topics from week 1 to week 7. Today I added some data set here, but just I will talk about that later. That is just something from the Jupyter Notebook. And by now I think everybody had this Anaconda, but if you don't have it, doesn't matter. So as usual, let me create a week 8 folder. So week 8. Oh, great. So what are we going to learn today? So notes.md, so this is a markdown. So I want to write down some of the topics we covered.
Sabine, sorry to interrupt you. What is the MD extensions? Just wonder because PY is Python,
Yes.
so I see that MD in
Uh,
different.
yes. As I said, it's markdown. It's a kind of
Okay.
HTML, but this is like kind of HTML, so you write it like this is H1. This is going to be heading 1. And if you write heading 2, uh, heading 3, maybe I think I don't have the extension of Markdown Viewer. Markdown Viewer. Markdown Viewer preview. Do I have already? Yeah, I have already. So if I have Control Shift P and the Markdown preview, what preview? Oh, not that. I think someone is waiting for. Let me try. Markdown. It would be nice if you guys mute the. If you mute, it will be really good for me. Okay. Yeah. Good. Control Shift P. I think I don't like this one. I have to preview. I'm not sure if I have installed this match, so it should work. Control Shift down, preview, enhanced. This is good. Let's wait a bit. Let me open it. Well, please open for me and make me happy. I don't know, something happened. It's not, but if it's okay. Oh, anyway, so this is the, for instance, I can have this. 30 days of Python was written in, or all these materials are written using Markdown, okay? So for some reason, my extension is not working this. I use the Markdown to write all these things, okay? So the extension is MD. For instance, this could be H2, #3, #4, could be 2 or 4. So that's why I write usually something like this. For some reason, the extension is not preview. It's showing a preview here, but it doesn't matter. So let's get back to the lesson. What are we covering today? We will have a look of the statistical module, the core module, and then after that we will see NumPy. This is numerical Python. Actually, they call it numerical Python. And then we will see a pandas, and then text blob, and then matplotlib. It's a data visualization library. And what else, Sharon? At the same time, maybe Seaborn. That's also the same thing. What else? This is the thing I planned to teach today. But before that, since we're about to start like data analysis, data science, machine learning thing, so I want to just talk about this field a bit. Yeah, so when it comes to these topics, data science, data analysis, machine learning, data analytics, whatsoever, all these need one thing in common. What do they need? What is they work on? Data. Yeah, so all these guys, they just work on data. So they call actually data is actually modern day petroleum. So you can get data. Where do you get data? Now, if you say that these disciplines work on data, if you say statistics, data analysis, data science, machine learning, actually all these guys, they use like statistics as a main tool. Statistics and mathematics actually too. Just like applied mathematics and applied statistics gives you data science and data analysis and machine learning. That's so you use the skill of statistics or the knowledge of statistics and machine learning. I mean mathematics using Python, using programming language, and you apply it on data, and then that is this. Okay, what are the form of data? Let's now talk about the form of data. Data could be small, a couple of text, or large. That's the size in terms of size. Now, where it in terms of size, but type. The type could be text, it could be image, it could be video. Yeah. What other form of data do you know? Audio. This is data. Okay, so these are a different form. So again, what are the source of data? Source of data. Where do you get data actually? Source of data. Are you going to generate? Are you going to make, or how? Because data is also hard to get. From institutions. From social media posts. For instance, Twitter, or I'm sorry, Twitter or Facebook or other social medias, and websites by scraping the website data, as we did last week. You remember? Last week we scraped that website and we produced this awesome JSON file. Actually, I just like it. So now, how do I make this smaller? Oh, it's even getting bigger. Yeah, as you can see now, we made this data last week by scraping that website, and so we created. So then, so we can say that we can make data by scraping websites. By the way, on this, what is this, Upwork, data scraping, there's lots of jobs there, lots of scraping data. Websites by scraping data. Okay, others, as I said, institutions collect data for different purpose. Yes, another is format, the format of the data, like some are structured data and others, the structured and unstructured and structured. Maybe what is structured data? Actually, it has some pattern. For instance, is it a structured data or is it just unstructured? What do you think? It is structured in a JSON form. Unstructured data is something like text. For instance, a Biden text is unstructured. It's just a text, a chunk of text. So that is not structured. But let me just give you example of structured data. Structured data. It could be JSON file, XML file, even Excel file. Then something in a form of dictionary, graph, and even there's CSV, TSV. What's another format of? By the way, do you know CSV? Comma separated value, tab separated value. Yeah, these are some of the data types which comes to mind. It could be more, but these are structured. It's easy to work on. It doesn't need much of a cleaning, because when it comes to data science, machine learning, data analysis, 80% of the work is consumed by data preparation and data cleaning and data processing. You have to clean, you have to remove all the garbage first, and then finally you get a clean data. And then on that clean data, you do your prediction, you do training model to develop a model. So if it's a machine learning, so you have a training data set, a testing data set, validation data set. And I think now we are going deep, so we don't have to go crazy that much because that is beyond the scope of this topic. I think, yeah. So, but just to give you the stage of the data science, data analysis, machine learning, the stages. First stage, you acquire data, acquiring data, or just loading the data, or reading the data from anywhere you get. That is. And the second, exploration. You explore, exploration. You explore your data. You try to understand what it has in the data using visualization, using descriptive statistics, and pandas help you. Panda. And this is also a stage of actually like cleaning. This is just the pre-processing. And then after this, actually modeling and the prediction. And then you have a result. then you have the result, and then a presentation of your result. This is not, but it looks like this somehow. These are the phases of just the data analysis. So you have a data, some form of a data, then you try to understand the structure of the data, and then if it's not clean, you should clean it by pre-processing and cleaning. And then after that, you have a clean data, you do modeling by training your model, then do prediction, you have a result, and then finally you do a presentation in different form. You present because you have now a result, right? Does it make sense, guys? Or am I just talking for myself? I don't know. Show me something. Here, let me see that chat box. Does it make sense? Did you understand? Yeah, that is the process. So now you are already about to join the data world. Okay, great. So now let's do some statistics. Yeah, what was this? Because I told you that statistics is very important for data science, for machine learning, for data analysis. So statistics, such a hard word for me even to pronounce. Okay, I have this data. So in statistics, we have this central tendency, the central tendency, they call it, I think, say something, I don't know. Central, is it how you write it? Yes. Then this, the mean, you can call it average actually, if you want. And the standard deviation, that's too quick. Then let's go for the median, the middle value, you know, and then the mode, the most repeated value, range, the value which is the difference between the largest and the smallest, and standard deviation. So as you may understand from the word deviation, so actually it measures how much it deviates from the mean. Okay, you may have a mean, so if you have a big standard deviation, so there's a big variability between the observation. But if the standard deviation is small, that means it's a uniform distribution, like something like that. Sorry for changing this class to some statistics class. Okay, and then what was the other? Standard deviation, yeah, variance maybe, variance. Okay, great. There might be some statistics people here. Variance, is this how you write variance then? Who really cares? But I think you understand that. Okay, let's move on. So this is what we are going to deal with. So let's create a file, statistics .py, because I don't like to call it statistics. It may affect, there might be some conflict sometimes whenever you use some kind of reserved word or module, you may have a conflict. So I will try to avoid practice or something .py. And then this is our data. Okay, so what's our plan now? Calculate. What is happening in here? Please don't disturb me. Mean, median, standard deviation, variance, and range, and mode. Okay, then depth, func, return anything. So this is the skeleton of a function. Everybody knows this, right? Everybody knows this. Okay, so instead I call it calculate, because I told you to give a mnemonic name. So mean means actually x1. If you have x1 plus x2, I think I have to show you some example nums, small, okay, 1 2 3, you have 3 data. What is the mean? The mean is actually 1 plus 2 plus 3 divided by the total number, these guys. So I will do 3. For me, that's 3. So if I print this mean, I should get, I think 6. It should be 2. Yeah, 2. Yeah, great. But you know, I do manual summing, you know. That's not how we should. Actually, we can use the sum nums, and then divided by length of this nums. So actually this is the mean. This is the mean already. So let's try print. Yeah, great. So if this is the mean, I will take this value. I don't need this, so I will put it here. But I have to take here a list. Could be some kind of data, you know. I call it LST or any, or L. You can call it L, but LST. Then here it's going to be LST, my list. So I have to return something from my function. So this is our mean function. Are you happy with it?
Yes.
What do you think, guys? And even you don't have to even to make it simple, you can just explicitly just return this value. Just you don't have to even, and even this is more shorter code. And now to check what is the mean, print, calculate mean, and what's our data? This, let's give it. I think the mean is actually 30.12. Yes, let's move on to the standard deviation. How do you calculate the standard deviation? Because now let's also learn the mathematics part, okay? 3. So imagine this is, and our mean will be sum of nums and length. So standard deviation STD, this is how you calculate. Each observation 1 minus mean square plus, and this value minus the mean again plus minus the mean and again square. So then actually again I have to have another square and divided by 2. Sorry, another bracket, the whole, and everything again. And I have to have this, I have to make it in a square root. Another easy way of making a square root is actually 0.5, the power of 0.5. Or I will show you standard deviation formula. Standard deviation formula. This is the standard deviation formula. The difference of each observation, the sum of the difference of the mean from each observation divided by the total observation. So I think if you didn't have a start before. This might not be that much easy to understand, but this is the formula. So I implemented this formula here. So we do the same here. So now let's do definition. Def calculate standard deviation, and then it should take a list. Okay, so we do this here, but now we have something which calculate the mean, right? This calculate the mean. So I can say mean first num. What's num? Total number of observation. This is how you calculate, right? You just count. And then the mean, how do I count the mean? I have already this, calculate mean. I can call it here, calculate mean, and then list. And then, what do? I do this part of the calculation. So what I do, standard dev, maybe I can just assign it with 0. I can start from 0 and then add every time. For list, for L in list, I have to iterate every time. std. By now you should know this one. And then what I do actually is, what is each observation? L minus the mean and time 2, right? Oh, is there anyone who can who is still following me? Okay. So now this part is actually the individual sum, like this one, this one, this one. In this case, we have 3, but you may have a huge number, so we have to use some loop. So we are making a square this every time, then we are summing this up. After summation, we will have this std, let's just std divided by n, and then 0.5. I think then we return itself, standard deviation. So this is my standard deviation, and let's try. Oh yeah, print calculate standard deviation of the data provided. As you can see, 9.67 something. Oh, great. Yeah, but you may say, why I go all this further? I can just import the statistics, because we have the core module. Statistics module is already there. And you can do statistics dot mean. And then you put the data, right? And then print this. Let's print this. And check with our value, actually. As you can see, we got the same value. You can do this, right? And then again, there's a standard deviation, actually. Oh, std, yeah, this is how they write it. And then print, let's compare our standard deviation. My standard deviation is a bit lower than this one, because in some standard deviation, as you can see here, they subtract -1. I'm not going to explain population standard deviation and sample standard deviation. That's a bit complicated concept, but for some standard deviation, as you can see, they subtract 1 from the total number of samples. So I have to do that, and it will be the same. Where do I do that? Actually, okay, I'll show you here before I just -1. Don't be frustrated, guys. You don't do such kind of calculation all the time. Just but now this value is equal to this one. My function and the built-in function, we are having the same value. Okay, so shall we move on? So we are done with this one. We're done with this one. Now we're left with median. How do we calculate the median? First, let's do again this. Median. Tell me the median of this. Okay, first I want to show you.
It is 2. Yeah, okay.
2. What's the median of this?
3.
Yeah, first we have to, no, you can say that because first you have to sort it. So it should be sorted, then 1, 2, 3. Then after you sort, you take the middle value. Then what's the median now? 2. But if we have in case like 5, what is now? Actually, we take the middle 2 value, 2 plus 3, 5. 5 divided by 2. So the median is now 2.5, right? No, so you just take the 2 middle value, guys. Median is. For this one, since it's odd, so you can just take this one. So that's median. So, in this case, we can just count it and so easy to calculate. How about in this case? First, we have to sort it, right? We have to arrange it. Why? It's not. Yes. The age of my students. The age of my students. Okay. So we have data here. So list age of students here. So I think it's about to know the length. So print length, then data. For instance, this is exploration. If you remember, I was saying that one of exploration of the data. So knowing the length is one of the. So as you can see, you have 25 observation. Okay, but let's do our thing again. Calculate. Calculate. This one's a bit tough. Median and then list. Okay. I will just say pass for the time being, and then let's just see. Yesterday or before yesterday, I think it was in the other class, I was talking about this mutation, and I think by now you guys should know mutation. So I don't like to mutate my data, so I go for sorted instead of sorting. So data sorted, and then sorted, I will pass the data here. Because sorted is already a built-in function. I'm not contributing anything here, okay? Let's see what we have here. So it will be in ascending order. As you can see, beautifully in ascending order from 19, the lowest to the highest. So it's so easy. Now, for instance, if I ask you like calculate range of this, it's easy, right? So what you should do is actually you subtract this one, this from this. The range is the difference. Okay, because at the meantime, I want to calculate the range. So lowest value, lowest. How do I get the lowest value, guys? The lowest value is 0 at index 0, right? Data sorted, index 0. Okay, so the highest value. How do I get the highest value? In two ways. This is the highest value. Actually, you can use just -1, right?
Yes.
Yep. So now your range is range, as you can see, it's already kind of reserved word, so I don't like to use this. Just you can return the value highest minus lowest, and this now this is actually your function to calculate the range in any data. Of course, if it's a number, great. Now, but we didn't calculate the median yet. Okay, so we did the easy part, but in the now, but we know at least how to source. So can you identify now the median? It's 25, right? So 25 by 2, when we divided it, it will be actually 12.5, and then we remove the 5, so it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Most probably this one will be the, yeah, let's do it. How do we do that? Okay, we have to check if the first we have to check num length of the list. Yeah, then we check if divided by 2 is equal to 0. That means if it's even. If it's even, we take two values, right? So I will show you again with the small data. Or do we have small data? I have to show you here. Nums. I think 1, 2, 3, 4. So tell me now, which value do I take to calculate the median, guys?
2 and 3.
Yeah,
Plus 3, right? Divided by 2, right? Yeah, but don't tell me that way. With index, tell me in index.
1 and
1 and
2.
2.
1 and 2. How you get actually that value? If we divided this by 2, the result will be 2. So 2, and then one of the value will be 2, and the other value will be n minus 1. So the index actually. So the index. So that means nums, and then I will get n divided by, no, yeah, n means in this case nums divided by
2.
Yes, 2, thank you. And then the other one will be
Plus 1.
minus 1. Yeah. And then again, you wrap this with another. Oh, sorry, we changed this to something we don't want. Did we over? And then we print this, and this is the median. So we have to reach a concept of this with a
You
big.
need to add a plus sign.
Hmm?
I guess you need to add a plus sign between.
Plus 1.
Yes, plus, right? This one?
Yes.
Yeah, thank you. Great. So now you got the idea. Let's implement this where? Here. If it's now we have to check two condition. If this is even, so we do as you told me that num. First, let's just start the median. Like the median will be, we don't know the median. So we can say the median is just none. Start with none. So the median will be here. List n minus, I think what's this, n divided by 2 plus list n divided by 2 minus 1. you okay, guys? This is what we did right there. Yes.
Yes.
And then else, that means the odd. So if it's odd, what we do actually just, if it's an odd, for instance, I will show you here. Well, was it? I removed already. So odd means 1, 2, 3. So what if it's odd? When you divided this value by 2, what will be the value? 3 divided by 2. 1.5. But actually, you don't care. So you take this value. So we can remove the division, I mean the decimal, and then we can just take this part. So I can change it to int or floor round. So actually, you can just int and divide it by 2. Yeah, I think this is what I need. And then the value, return median. Okay, this is our median. I don't know if you like it or not, but let's try and check what we get. And we don't need this anymore. So print median, no, calculate median, and then our data, and let's see the value. Yeah, 26, yeah. But let's also check with the statistics method, statistics, and then median, and the data. Yes, we got this. Wow, that's great. Okay, what's left? Let's see. Done, done. Standard deviation done. Variance. Variance is so easy, guys, because variance is the square of standard deviation. So you can say variance is equal to calculate standard deviation, and you pass your data here, and then you multiply it by 2, and that's your variance. So print variance. But why I'm just making a variance? Like, yeah, it should be written like this. Oh yeah, so this is the variance I got. So let's check the variance by doing the statistics dot variance and data. Yep, the same almost. Okay, what's left? I think we are left with mode, guys. We have to have a break because the mode is a bit complicated, but we have to do it. And if you want to also have if you want to try it during the break, you can try it during the break. So let's do the mode after the break, and after that we will learn NumPy. Yeah, so see you after 10 minutes. Yeah. Welcome back. So this will be then now I know how to write variance. I think this should be a, so variance. So we solved that, and now we are left with mode. So who could tell me the mode of this by just looking at this? I think similar to median, to know the mode, first we have to sort it out. Yeah. Okay, so as you remember, sorted, and then you just drop the data here. You have that data, and let's print. Print, and let's see the most frequent value. What's the most frequent value for you here? 19 1 times, so it is not 20 2 times 2 times 1 times 4 times 1 times 2 times. But now, as you can see, I'm making a kind of what? Do you know this tally? 1 times and 2 times. I'm just making a kind of frequency table, right? A value, and I may count or frequency. And then 22, how many times? 2 times. And 23, how many times? 1 times. Yeah, it's a very hard job to do. That's why they need to learn programming. It will take forever doing such kind of things if we have a huge amount of data. Yeah, even I'm just puzzled it out. 24, how many? 4 times, I think. 25, 1 times. It goes something like this. Do you understand what I'm trying to do? No, instead of you manually doing it, we should deploy Python to make something like this for us. Yeah. Frequency table in statistics they call it frequency table. Frequency table. Yeah. Frequency table. Someone score 1 2 times 2 people. It could be 2 people, or I don't know. 2 5 times 3 4 times 4 2 times 5 1 times. Which one is the mode? What value is the mode here, guys?
2.
2 is the mode. Correct. Yeah. Again, another tally. Which one is the mode here?
2.
Yeah, 2 occurs 9 times, so it should be 2. Yeah. Great. So we are going to do such kind of a mapping. So what kind of data structure are we going to use to make something like this? So it's a kind of key value. So what kind of data structure do you suggest to solve something like this?
Directory.
Yeah, so dictionary is good for this. So sorted data, first let's sort. We sorted this. After that, let's change this to a dictionary. How? Freak table, and then just let me just declare an empty dictionary. And then I loop through this, I iterate through for an age, okay, because those are age in, or maybe just I can just age, yeah. In sorted data, first let me just print the value out and show you, because it's good, right? And then if I do this, I printed out all of them. Yeah, but that's not the point. I want to count them. Okay, how? Actually, if age not in a freak table, then what I do actually, I add it to the freak table. Okay, go to the freak, and then it will be counted 1 times. Else, if it's there, what I do, freak table, and then the age, and then again, I increment by 1 times, plus 1 times. And then at the end, if I check the freak table, no, console, freak table, and then you may see, let's try to do this now. Have you seen some kind of dictionary over here? Yes, you should see, but let's do the import. I think this from p print import p print. That is so I want to print it like beautifully. Now you can see it properly. Yeah, by now you know p print, right, guys? So so does it somehow looks like this, guys? Yeah, kind of course you can't replicate this to a code. We just, I mean, get something similar. This is just a dictionary. Okay, now as you can see, 24 4 times, 40 4 times. Actually now we have two candidates, 40 and 24 are the mode. Okay, but now we have to sort this to know which one is the, we have to sort it out, right? We have to sort this. So which value is the indicator of a mode? The value is the indicator of the mode. So the frequency is the indicator. So now again, we have to change this value somehow differently, guys. And then we have to store it somehow. Let's try to change that value. We can change, do you remember items? Okay. Let me show you. Frequency, freq table dot items. Do you know this, guys? I will show you. What? Actually, it changed to a list of tuples. Yeah, now it looks somehow different, right? Yeah. Now we can reverse this value and even let's maybe try to sort. I'm not sure what result we can get by sorting this. Sorted the value. Sometimes no, so we didn't get anything better, right? Another good solution I found on the internet, this one better. Of course, we can solve it in a long and complicated way, but I will just a very popular question. Sorting dictionary. And this is how I search actually, and I found a very good solution. This one. So I will just take this code and I will explain to you. So whenever you get stuck, most probably you come to this popular site. By the way, the traffic of this website is about 6, the 7th or the 6th, in rank of traffic. So it's very popular. Every developer spending his day and night maybe here. So let's take this code and I will explain to you. Yes, so now we don't need this. Okay. As you can see now, do you remember this comprehension list? Comprehension list. So what like for KV in sorted, this actually first we change it to the freq table to list by using this. And then we have this lambda. the item, that means one of the item from here, it's an iterator, and we are interested in actually the value, because the value is an indicator of the mode or the frequency. Then again we change the structure of the frequency table, again, and let's store this and print freq table. And if you see this, actually now you may have as you can see now, somehow different structure, as you can see. Yeah, 19 one times, 23 one times, 25 one times, 27 one times, 33 one times, 1 times, 61 times, 22 times, 22 2 times, 26, 28, 24. Yeah, so our value is actually the last value. Yes, how do we get that value again? Maybe I think the easy way to get is items, and then after items we may take out again with minus value, and then we get out the last value. What did I do wrong? Predict items. Let me try again. What do I have? We have this. Okay, it's yeah, but of course we don't really care. We can even change it to a list. Changing the list, let's see how it looks like. Yeah, but if you change the list, do you know you lose that what? You lose the key, the value actually. So just you see that. Then now instead I don't want to do that. Maybe what I do, frequency table dot items. What do we have here? Is it? Yeah, here what we have is actually the dictionary. So then I want to change to items. Then now this give us dict items. So how to get the last item from dict items. Somehow, oh yeah, as you can see, they use a module, but I don't want that, to be honest. Another solution, I prefer another solution. Yeah, I prefer such kind of solution. Yeah, so we are interested in more of in okay, sorry. We are interested more of, sorry, in the values. So we can even say just freq table dot values, and then if you go -1 and you get the last value. Print. And it could be 40, right? What? What's happening? Okay, make keys. Oh, no, I made a mistake, because keys, and then I have to have this, and then subtraction. Maybe I have to show you what we get from this. We just get the keys. That means Let's see here. Yeah, so we just got only this. So our values actually are this, the last two, but most of the time you can take just one of the most frequent values. So just let's take how dict, kiss, and it should work. But why not for me? I have another. I saw something before. Is it another? I have. Okay, let me see. My previous code. How about if I just leave for you and sorted it out? Because this is a very good challenge to take, because sometimes it takes some time to yeah. So your challenge will be now, as you can see now, the mode is actually 24 or 40. So your challenge will be just take out this value, either this, the last values, okay? So now let's just finish our function. Our function is going to be called calculate diff calculate mode, and we take a list, yeah, and then we wrap all the code we have been doing here into the no. So indentation is one of the most important thing in coding, right? So we have to indent this properly, and then it needs to be indented properly. So you need to finish this, just a couple of lines or one lines of code to take out this value, the last. So the mode will be either 24 or 40 or both. Now you have a chance to even to show both are the mode and they occur 4 times. But if we use actually the statistics method, statistics, and just mode and the data, it just gives you 24 and it doesn't tell you how many times it happens. So have you seen, it just gives you 24. So it's your code is actually, our code is much better than what is in there. So it was in short, all this, the central tendency like median, mean, standard deviation, variance, range, and mode. Okay. So I don't like to spend too much time to solve the last, but I think it's almost done. Okay, great. I think now it's time to go to another topic. But even the statistics module, maybe if you get a job somewhere as a data analyst or something, don't depend on this statistics module. Why? Because there is a better module that's called Numpy. Yeah, Numpy does everything for you. So now let's run Anaconda and work on Numpy. We don't see everything about Numpy because Numpy by itself is big. And it's a very important tool for people who are working in data science and machine learning. Okay, so this is my Anaconda navigator. So Anaconda comes with lots of tools, as you can see, but most of the time I prefer the Jupyter Notebook. So let me run Jupyter Notebook. It opened in another screen, but I will bring it here. Yeah. So when it opens, it looks like something like this. So actually you see your computer on some server. The server this is the local machine. So it uses the local server or port, this 8889. And now I can go to the desktop. And then I want to go to our folder or project. And then I want to work on day 8. Great. And then as you can see, this is what we've been doing. So now, if you want to create a file, as you can see, either a Python file or a text file, or if you want to create a folder, for instance, and then you can rename it. Rename by something like this. Yeah, but we don't really need this, and we delete. And you may create also just such kind of file, text file, and you can write, because we deal with also text file, but we don't need that also. I just delete that again. And now I want to create just this Python. When you create a Python file on Jupyter Notebook, actually if you see, the extension is actually IPynb. Okay, it's a bit different, so don't be surprised. And now I think if you have never used this, is just a Python print hello world. After you then shift enter, or you can just press this. What? No. I have to get it up. I mean this run. And then it comes here again. 1 + 2. Shift enter. And maybe you can also, like, you can click somewhere else. Now this is not active. And if I press A, it append. Yeah. And if I press B, now, it will add additional cell below B. Yeah. If now I press A, it will create a cell before C, as you can see. So it's just a shortcut. So you can come the shortcuts. Where are the shortcuts? You can come here and study the shortcuts. Yeah. So I'm just telling you the common shortcuts. So we don't need them. This, you just use this cut. And now again, yes, I think by now, print by now, you must start loving Jupyter. Yeah, Jupyter Notebook. Yeah, yes, because it's great. And in addition, we can write note. Yes, Jupyter Notebook is awesome. Yes. And I want to make it, and then you can change this to markdown. Yeah, because you can take also notes. Yeah, but this doesn't make sense. Let me check it up. Yes, I called, since we are learning, Numpy. Yes, Numpy. I wrote something about Numpy already in another file. I will just copy that and paste it here maybe, and that makes sense. So like Control Shift Enter. As you can see, NumPy stands for Numerical Python, is a core library for scientific computing in Python. So even it's efficient, very efficient. I don't know how it calculates things, but it's really very powerful. More powerful than list or the statistics module. So please try to use this whenever anything related to numerical data. It provides a high performance multidimensional array object and tools for working with arrays. That means list, a kind of list. It contains the data structure needed for storing and accessing arrays. It has more simple operation and functions for computation for arrays. In addition to numeric data types, NumPy can store other data types such as strings. Unlike lists, NumPy must have the same data type for all the items. Yeah, all the items must be the same kind of data types. Yeah. So great, that is NumPy. So now let's learn how to import NumPy. How to import NumPy. Actually, this is import NumPy. This is how you import NumPy. That's all. And maybe to check the version, print NumPy dot version. As you can see, I'm using 1.192. Maybe you might have a latest version, but this is okay. I don't need these lines. And now let's do some NumPy array. But before that, how do we create a list? 1, 2, 3, 4, 5. Is it a list? I need an answer, guys.
Yes. Yes, it is number list.
Yes. It's a list and all the numbers are just integers. So they are just ordinary list. So type, type actually, print type to know if they are lists or not. Yeah, as you can see, they are lists. But we can change these guys to NumPy array. Yeah, but most of the time, these data scientists, the guys, and the data community, they usually import NumPy as NP. Okay, so let's also call it NP. Now I want to change this to an NumPy array, and I will just np.array, and then you just pass this data, or maybe just put it here, or you just put nums. And if you know NumPy array, as you can see, it's changed to something different. Why we need to change it to this? That might be a question, because it's easy to deal with these guys. For instance, you have a list. Can you multiply these guys by this? Nope. You have to loop through. But these guys are so easy. Let me show you. NumPy, because I have to tell you in advance why we need to. If you do this, have you seen? What? So easy to work. Maybe if you want to add with this some numbers. So I want to add 10 to every of these values. And then if you see, what? Just 11, 12, 13, 14, 15. Yeah. So the reason why we change it to NumPy array, because NumPy array has tools to working with arrays. It contains the data structure needed for storing and accessing arrays, and it has simple operations and functions for computational arrays. And there's also matrix calculation and other things. Okay, now I think we have been working with the data. Let's take our data. Where was our data? Our famous data. So let's take it here. Is it a list or is it an Numpy array?
List.
Yeah, it's a list. Now let's change it to Numpy array. Okay, we can just store it with the same name, Numpy array, and then data. Okay, so last time, as I told you, this Numpy has everything. Numpy.mean, and then you can just, do you remember the mean? So easy now. Numpy.standard deviation. Standard deviation here. Did someone left? Okay, then data. Yeah, do you remember this value? Yeah, if it's too big for you, you can use round. Yeah, round is just chopped everything off, so maybe we can round off to the second decimal. Yep, by using 2. Okay, then np.median, median and data. np.mode. I'm not sure if it has mode. Is it mode that? Let me try data. Yeah, I'm not sure it has a mode, but for that we can import another. They call it I think what was it? SciPy. Okay, let's import SciPy as S. I think just SciPy is okay. So you have to again run through all the process, and now SciPy.mode. Let me see what the mode is. SciPy mode. Sometimes it's good to come to the documentation, guys. So this is the documentation, for instance. Now I know I made a mistake. So because the reason why, oh, I think I'm opening lots of things at the same time. Where was I? And it's also good to give name. So let's call this this file numpy, maybe practice. And the reason why actually, and instead of the SciPy, I have to use from SciPy the stats module. That means like the statistics module. So in that case, I should have used here stats dot what? SciPy has no attribute. No, it has, please. Bye. Okay, maybe I have to from SciPy import stats. That might be an easy way, just importing only the. But why now? Well, I think I didn't run this, so now I can just use the stats. Have you seen now 24 is actually the mode, and it occurs 4 times actually based on our calculation last time. It's not only, I mean, this 40 also occurs 4 times. It's a kind of a chance that 24 became the chosen one, but I think we can also take multiple mode if it occurred two times. I'm not a expert in statistics, so anyway, you got the point. Yeah. But for standard deviation, did we do that? NumPy don't variance, and then we give the data. I think it's just a var. Yeah, 93.54. And this is just, as you can see now, we use NumPy to do just basic statistics calculation, and it's very powerful. Okay, it's not actually the only use of this. We can also change different tuples, lists, and any kind of data type to NumPy array. Guys, are you following me? Let me check. I think it's a kind of a wake-up call. So I think there was a chat already going on. So let me just check if everybody's here, or am I just talking to myself? Okay, so everybody's here listening to what I do. Yeah, because it's good to know, you know. During a 4 hours lesson, if I don't check you once in a while, and so it would be might sleep, no one knows. So that's why I'm just bothering you once in a while, just to write one. Yes. Okay, great. But I want to also import one module, and that is actually matplotlib by plot as PLT, and it will help us to draw some graph. And yeah, let me show you, for instance. Okay, x. Do you remember, guys? X is equal to mx plus b something. Does it just say something? I mean, does it ring a bell? Something like whenever you see this equation?
Yes.
It's a linear equation, guys. This is a linear equation, and it has slope. M is slope. Slope means gradient, a change in some kind of distance, and B is actually the y-intercept. Yeah. And we don't write in Python like this, but I have to put something like this. In mathematics, they call this just a linear equation, but something like this somehow, y hat, and then they write it like this and like this, and this is actually a machine learning model. A machine learning model, and it is linear regression. Huh? Why? Just this is a machine learning? But of course, you guys even you don't know what machine learning means. Actually, machine learning means you have a data, and your data, or maybe your model or the program you write, learn from the data, from the previous data. You give the weather data of last year, and it predicts the next year, or yeah, based on previous data, based on experience, like the way we learn, you know. Yeah, like the way we learn. That is, for instance, for a baby, the first time when they see the candle, it's just so nice. They run into the candle and they just touch it, and of course it burns, and then they cry. But next time they don't touch it, because they learned from experience. And after that, even when they see something which looks like a candle, they may run away. So actually they they call that in machine learning overfitting, because they think that actually it's not. So the model is not working very well. So if the baby is like afraid of everything, which looks like a candle, so that means your model also may just read everything wrong, as in a positive result. Anyway, I don't know if you get it or not, but what I may suggest is the Elements of AI from Helsinki University is a very good course material. You may get to ECTS for taking that, and also data analysis with Python in Helsinki University. I think that's also one course which is really good, very in-depth. That's also, I think, open for everyone. And also in Aalto University, this fee take, yeah, I think Finland is really doing great. Fee take is like Coursera. You can take lots of courses from almost all Finnish universities. You don't have to enroll, and it's I mean, you don't have to have a student status. You can take any kind of courses. Most of the courses I'm talking about, they are related to web design, machine learning, data analysis, embedded engineering, something. So you may consider this the FITEC. I will share with you on Telegram. Maybe most of you know already. Okay, so what's the point here? Now, let's come back to, because why it is that, because as you guys, we didn't assign the variables, so it doesn't work. So let's say X, we have some value numpy array, and then we want to write -2 -5 -4 and -3 minus what is that, 2, I think -2 -1 and 0 1 2 3 4 and 5. Well, what does this tell you guys? It's just an integer, right? From -5 to 5, yeah? Yes. And my y will be, actually, I want y to be 2 times the value of y, actually 2 times x plus 3. Let me print the value of x. Y. Oh yeah, I forgot to put this in a, yes. Is it what you expected, guys, from x? Yeah. Is it what expected? Yep. You just get this and you get numpy array. Okay. But let me just remove the plus. And what do you expect from y? This will be?
-10.
-10, yeah, because numpy allows you just a simple multiplication, simple division. So yeah, -10, -8, everything will be multiplied by 2. Okay, great. So how about if I want to draw the slope of this? So we have this PLT dot plot, actually, and then you give x and y. So yeah, it should be, it's a linear, right, as you can see. And if you want it to be scattered also, just scatter. Scatter, that means it's without this. I think even you can give it a color. C is equal to red, for instance. And you can red, or just you can just, or maybe what color, any kind of color text, orange, or maybe brown. Brown and maybe purple is good. Everybody likes purple, don't you? Okay, I don't know. But something like this. But sometimes when you want to visualize data, you want to have, this is the x-axis and this is the y-axis. And actually you can say PLT x-axis. And then you give, we can say, for instance, the temperature or the pressure. But now we just have just x-axis. Oh, Matplotlib has no attribute x. Okay, I forgot maybe what was x label. X label is actually the, yeah, so x axis, and then PLT y label. We can call it y axis. And maybe we can, of course, if you are, for instance, working with the pressure and temperature relation, this will be pressure. Okay, let's imagine this is the temperature by pressure by temperature. Yeah, we've seen this sides. The temperature, when the temperature increase, the pressure also increase. And then let's give title PLT dot title, and let's pressure, no, temperature versus pressure. Usually something you put in the x-axis is actually the independent variable, and this is the dependent variable. What does that mean, independent variable? Temperature is a temperature. It cannot be affected by anything, right? So then you have a temperature on the, on water pressure or something. When you, then the water pressure or the environmental pressure could be affected by the temperature or something. So you should put anything independent in the x-axis and anything dependent in the y-axis. And this is just so, but maybe this is just so clean. So there is this package, Seaborn, import Seaborn as SMS. Then you have to set, to make use of that cns.set. And then after you do this, this will be somehow like gray background. Okay, let's see. Yeah, now as you can see, it's a gray background. So it looks a better graph. Yep. I think if you have any question, just let me just give you a chance to talk. If you have any question. Seems just leave me alone. I don't have any question. Okay. Then maybe I can solve this. Do you remember when I was generating this data? It's tiring. Let's just generate data in a more elegant way. Okay, now let's see X. Maybe, do you remember range? That's the better way to ask. What does this mean? Range.
It will give you values from 1 to 10 or 0
Yes.
to 10.
A value from 0 to 9, right? Yeah. Let's put value from 0 to 9. Let's see, print X. Yeah, it's from 0 to 9, but it just gives you something like this. So you can change actually this to a list, and then you can see from 0 to 9. So in this case, you don't have to create something like this. Instead, I should have created something like this. Let me show you. Lists and then range and then -5 and the end will be actually -6 and then 6. Yeah, I think I got the same result, right? Yes, I got the same result. But the importance of this, you can make it even bigger. So you can take it to 60 now. You don't have to generate data manually. And oh yeah, our data is plenty. Have you seen? Yeah, so it's really quite a lot of data. Even though we are using scatter, and of course, if you put here, for instance, 10, what does that mean? We are stepping 10, you know now. Now the data will be small again because it's every 10 point, but we don't want that. And maybe I can also just reduce that to 10 and we can have something like that. Okay, so just to practice more, how about, is everything a linear equation? No. So let's do something. X is equal to Numpy array, and then in range from -3 to -3 to 3 for the time being. Who cares? Then y is equal to actually x squared. So square plus 2 times x plus like maybe actually 6x. I know this equation, and then 9. So it's a perfect square if you know quadratic equation. And so now we have this. Now if you want to plt dot scatter or plot, doesn't matter, xy, you may have a kind, have you seen just a kind of a parabola. It's a parabola, something like the parabola goes something like this, upward parabola, because this will be the y value is always positive. Yeah, no matter what the x is, I mean, no matter what x is, the y value is all the time positive, as you can see. This is a square. Maybe the lowest value is 0. Yeah, 0. Yeah, the lowest value is actually going to be a 9. Yeah, I think so. Oh, okay, I think. Let's take this too much to the negative side, let me say. Yeah, as you can see now, we properly see it's a proper a parabola. So in this side also, I want to see somehow. Yeah, so it was hard for me to to give equal proportion in both sides. But as you can see, it's a kind of course, it's not a kind of, it is a parabola. So you can do even graphs, visualizations, scatter plots. But if you don't like it to be scatter plot, you can just say plot and it will be a line, something like this. Yeah. And as you can see, even maybe if you just change a bit, most of the time, these 3-degree polynomials, and they have such kind of this wavy, something like this kind of nature. And if you have a plan to just learn machine learning, this really helps you a bit, understanding just simple graphs. because linear regression, multiple linear regression, polynomial regression, those kind of. Okay, now plot that x scatter x y. Yeah, have you seen now? This has this kind of, because of the degree 3. Odds, if you have just odd number, most of the time it has such kind of. But if we change this to even 4, it will be somehow again kind of. I don't know how I explain this. Okay, so I think this is too much already. No need to talk about. So now you know that whenever you have some data, x is equal to numpy array, and if you have some number 1, 2, 3, so you better, guys, if you don't have any question, there's sound coming to me. Yeah, print x. Yeah. Okay, so you can even multiply this by 2. It's easy, as you can see. Now everything multiplied by 2. You can divide it by 2, as you can see. And even you can add just to every of the items. 3, 4, 5. Yeah. Okay. So that's why we need NumPy. It's so easy to use. Can we also do exponential power? Why not? So you should expect now this is going to be 1, 8, 27, right? Of course, it doesn't affect the original, just we have a copy here, okay? It doesn't affect the original. That means if I just print x, I have to have the original. We are not mutating the original. Okay, great. That is one of, but whenever we do this, we can store this data as in, for instance, type, data type. By default, it's integer, but we can say float. As you can see now, it's a float value. Yeah. By saying this in, for instance, string, stir. Yeah, it's string. Do you think this code will run? Let's try. I don't know. Yeah, of course. I was expecting it doesn't, but yeah, that's true. We didn't run because it's string. So we don't do multiplication of strings, right? So it fails there because this operation. Now, as you can see, all the numbers are string. So while you are making this NumPy array, you can also change the data type. Yeah. Another funny thing, actually, for instance, if you have this 0 and -1, and if you change this to a bool data type, what do you expect in X? I mean, what do you expect here? Actually, this will be true, 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 and false. I think this also, I don't know what this is going to be. Let's see. Yeah, of course, this is just only all, I mean, because in programming, 0 is a falsy value, but the rest values are truthy values. So this is, do you get the point, guys? Yeah, falsy value we have only here. So because if you change this value to a Boolean, so you get true and false, because we agreed that Booleans are only true and false. Yeah, so how about if I have other data types, for instance, y and numpy array. Now I may have 9.81, 3.14, 2.27. I have this data. So all are actually floats, as you can see. Can I change them to? You can change them to an integer actually. So what you do as type and then change them int. Yeah, 3932. But as you can see, there's a loss of data. We lost them. We lost 8.1, we lost 1.4, we lost 2.7, but still we can change it to different. So you can use as type method to change it to int or float or string. We can also even change it to string now, as you can see. Okay, so how about if we want to create multi-dimensional Numpy array, how about if we want to create something like this, 1, 1, 2, 3, and then 4, 5, 6. Yeah, have you seen what it looks like? This is a 2-dimensional array. So 2. Why we call it 2-dimensional array? Because it has 2 rows, as you can see. But in list, we call it a list of list. A list of list. We just call it a list of list. How do we extract the first row or the first value? We can extract actually in different ways. 2-dimensional value. So if you go, for instance, 0, you are extracting the first row. Let's see. Yeah, the first row. And if you go to, again, 10-dimensional, and if you go to 1, you are going to extract the second row. How about if I'm interested to extract the first column like this? This one, 1 and 4. That's tricky, right? 2-dimensional, 2-dimensional, and then actually I should say I am interested in all the rows. So if I'm interested in all the rows, I can just do this. That means I don't want to leave any of the rows. Then I take this side. But when it comes to the columns, that means this side is the row and this side is the column. So if I don't start, let me show you maybe something. If I do something like this, I am referring to the first row. How about the column? All the columns. So this is actually all the first. How I managed to extract all. Sometimes this is tricky. Zero. Yeah, this another way of from the first column, from the first row, this one. If we do this, we should extract 3, right? Yeah. For instance, if we change this to 1, that means the second row, the second row, and this will be, yeah, any of the, so 0, 1, 2, this give us 6, for instance. But what I'm interested is actually to extract 1 and 4. Maybe I want to see other code which I have used before. Okay, so how about if I use 0 to, yeah, 0, as I told you, it refers to the first row, the first row, but all, and yeah, just okay, and then let me see. That is just, that means the first row, and then from the column, from this, and just we take out that. Okay. Okay, maybe if I put up to, yeah, up to 2. Yes, this is what I was, because as you, this part is the row part, and this part the column part. So row from 0 to, that means I am interested in all the rows, okay? It doesn't include the last one. Okay, columns, I am interested from this to this, but it doesn't include this. Then if I want to just select these guys, this 1, 2, and 4, 5, then I just increase this by 2. Yeah. But if I'm interested only these guys, 2, 3, and 5, 6, what I do is actually I have to change this value. So instead of this, actually I should change from this. And I have to leave this up to the end. 2, 3, 5, 6. It's a bit tricky, but you don't have to, guys, remember such kind of things. There is the documentation. No.
Hey, Sabine, I have a question.
Yeah, wait.
Could you
Yeah, I'm coming. NumPy documentation. So such kind of things, you have to just read from a documentation, NumPy documentation. For instance, this, after this, it's all about reading documentation. So don't try to memorize everything. Yes, the question.
Yeah, could you please show us 0.0 we were discussing on the chat room? So what will be the result?
Chat.
To dim array and
Chat room. The chat, I think it's 0, 1, just 2-dimensional array, 0, 1.
So 0.0.
0, you mean colon? Okay, 2 dimensional 0 colon, you mean like this?
Yes.
Okay, so let's see this, what it gives you. This is clear that, let's see how it was our 1, 2, 3. So it just gave you the first row,
What if we just wanna only take out one? How do
Which
we
one?
gonna do
This?
it? Yeah, from the first row.
Yeah, that
If
is
you wanna see
easy.
only one.
Yeah, that's easy. Just to go to this and then go 0. Another row. Yeah, because this one already gives you this helps you to get the first, and then you get 0. That's one way. Another way, 2 dimension again. Actually, if you want the first row and the first row from the first row, and you are interested from the, I think this also give us 1. That means from the first row, the first column. Yes, let's see if there's other methods which I can add. I can actually, there's also reversing this method. If you see 2-dimensional, we can reverse this using -1, and we managed to reverse this with this. So just reverse order. Another actually methods which I want to show you, the zeros, numpy 0. Sometimes you may be interested to produce some shape but by the way, before that, I want to show you the shape of this, the 2-dimensional shape. As you can see, what's the shape of our, so the shape is actually, it is 2 by 3. That means 2 rows and 3 columns. 2 rows and 3 columns. It's like a tuple. So yeah, we size, if we want to know the size, actually the size actually how much, how many? It's 6 total observation or total numbers. We call them size. So let's go to the zeros. What? numpy.zeros. And then we may be interested in 3 by 3. And this helps us to create actually zeros, empty value array. Why I need empty value? For now, because this seems silly, but actually sometimes you need to have some created empty value with 0 or just empty value. So maybe, for instance, to make this empty, last time I was practicing, and data type, I think. And if you just this, what data? Okay. Data type. Okay, maybe stir. Yeah, that's not true. Yeah. Stir. So this created for me actually, as you can see, empty string for all the values. If you put this int, it will be just 0. By default, it was creating a float, as you have seen it. It was like this. And opposite to this, I think we have ones. Ones. Why ones? I think there's no that. Yeah, the importance of this, for instance, if you multiply it by something by 50, you get some such kind of value. And after that, specifically, maybe you can modify this. It's possible to specifically modify one of. So you slice out this section or this section, and you can do the slicing part. I think it's getting too much time, and I can't cover everything related to NumPy because it's a huge topic, but this is a very good starting point. And maybe there's one thing I want to show you. After that, it will be the last, I think, what was the slice? Not the slice, this np dot line space. Yes, yeah, this is really beautiful. So actually it takes a kind of 5, for instance 5, and then if you do something like this, it gives you just but I have to give some. So this means your initial point is 5, your ending point is 5. So, and you need only 2 data. So how many data can you generate? Between 5 and 5. And if you are interested only 2 data, how many data can you generate? Yeah, actually, as you can see, the 5, the starting point and the end point, it doesn't even make sense. But we can, for instance, generate 10. And we didn't put actually the spacing. I think I line space numpy. I missed one parameter, maybe the order of the parameter. Starting point, stop, and number of the counters, and end point. So I think number, yes. So I have to put the number like, for instance, 10. And then if that doesn't work, the second thing you should do, check the boilerplate code. An example, for instance, we have starting point this and this and this. And it got from 2 to 3. There are a lot of numbers. And but I think in my case, oh yeah, guys, you should have told me because I didn't change this. I have to make, for instance, if I make it up to 10, it could change, yeah? So actually the point is generating numbers between 5 and 10. How many numbers do I need? How many numbers? 10. How about if I want this? Yeah. Okay, now it's a tricky question. How many numbers can I get between 5 and 10? What? How many? I think it's quite a lot. It's quite a lot.
5.
Hmm?
5, right?
How much?
5.
No, not like, not in a counting number, but including decimal numbers, floating numbers. As you can see, it's quite a lot already. I can get even more than, I can get 1,000 numbers, as you can see. So all these numbers are between 5 and 10. Have you seen them? So whenever you increase this, the distance between each point, yeah. So why I need this? Actually, sometimes whenever you want to generate something, okay, X will be, I want to generate between -5 and 5, and the total number I want 100, and Y will be again 2 times X plus 5, and I want to just plot this scatter plot, and then XY, and then the color, it's going to be orange. Who doesn't like orange? And as you can see, it's quite a lot of points. If I reduce this, you will see the scatter points. Have you seen that? So it's an easy way of generating data. Data is so expensive, it's hard to get. So sometimes this kind of methods allows you to create data and to generate something, to generate data. And now I will show you also how to make graphs. They call it this using random number. np dot random dot normal distribution, normal. And for instance, I want to have a mean of 5, 5, and maybe a standard deviation of 2, and I want to have 100, maybe 1000 data. Have you seen? Now I created this data. So now the mean is actually 5, the standard deviation is 2, and this data is generated based on this given. So as I told you, data is hard to get. So, and just let's plot this penalty dot. There is this hist. I think I will histogram, and then you just put this value. Maybe I can call it data, and I can put the data here, and then the beans means the bar, the histogram bar, 50 most of the time. Let's see what rectangle object has no property, beans. And if you dot random normal, let's see. Beans. What does that? Oh, it's created already. But what does that mean? Has no property bean. Oh, beans. Sorry, beans. So the beans means this is one bar. The bars are the beans, and we don't want to see usually plt.show. And it's good to, yeah, now as you can see, we managed to create such kind of distribution table based on the fake data we generate. And if you just take it to this 10,000, and it looks like somehow a real distribution, something, yeah? Because the data is now, let's put it now, yes, 100,000, but don't go too much. 100,000 is already quite a lot of data. And the beans, maybe let's make it 200, and then you will see some kind of, yeah, they call this the normal distribution. So normal, the mean is here, and 95% or 97% is somewhere around in this region, and the rest of the 2.5 something percent will be the other. I will just show you this because it's normal distribution, and then after this you will have a break of 5 minutes. Oh yeah, so but I want to see some logical thing. Yeah, this has something. As you can see, 99.7% will be in this. Actually, no, see, this is the, yeah, as I told you, from here to here, 95.5%. And this region, yes, so it has its own calculation, but I need, yeah, this part and this part, these two together, they are about 68.2. And this and this, actually, it's going to be how much? 26, 27 point something, and this together 4 point something. And anything after this, actually, they call it outliers. Outliers. For instance, in our data, which one do you think an outlier here?
60.
60 seems an outlier, and also again another number to consider.
19.
Yeah, 19, yes. So whenever you deal with this data, you have to learn, you have to investigate, you have to get closer to your data and understand, because just it spoil your data, it just destroy your result, okay? It just destroy it. And also whenever you have time, try to understand this distribution, what this beautiful shape mean. Of course, you did statistics, but this concept usually just vanishes after you complete the course. So it's good to revise, refresh this concept. I check it now and then, it just vanishes. So it's good to check now and then, because it's really the core concept of statistics. Even you can see here, then they call it even when it's very sharp, and when it's somehow flat, and somehow this. It has also a different meaning in the nature of the data. So that actually will help you to be a data analyst or data scientist or machine learning expert or specialist. Okay, now I think we should really stop here talking about NumPy, and then after the break, after 5-minute breaks, we will start the beautiful panda. Yes, panda, who doesn't know panda? So we will talk about this animal. Yes, let's have a break. Great. 5 minutes break. Okay, welcome back. So we saw just NumPy. We didn't cover everything related to NumPy, and we don't have to, because it's not about to cover everything related to NumPy, but to let you know that there is the so-called NumPy package, which can you use for numerical purpose, or they call it scientific computing whatsoever. Now I want you to let's talk about this pandas. Okay, why panda? So maybe panda. Am I talking about this kind of sleepy animal, something? Yeah. No, it's I'm talking about a package, a Python package, which allows you to read data. Maybe I think you can go to 30 Days of Python or other tutorials and maybe see, because on 30 Days of Python I put okay, well, oh guys, I think this 30 Days of JavaScript. Yeah, whenever you have the same name. Oh, I don't know what's happening, to be honest. Okay, great. Pandas. So it just goes step by step, and Pandas is an open source, high performance, easy to use data structure and data analysis tool for the Python programming language. And then, for instance, this is a panda series. How many columns do you see here, guys?
Two.
Oh yeah, you see 2 columns, but actually in panda, it is just now we have this one is 1 column. So series is like it's like a Numpy array, but it's a different data structure. This is just the index of this data. Countries series again. This is an index, but this is the real column. And the cities. Okay, now we call this series, okay? But this, we call this frame, data frame. Okay, what's the difference actually? We merge these guys, how many? 1, 2, 3. Have you seen? We merge them. And then we create a data frame. So data frame is actually a kind of a table. It has columns and rows. And also in another way, Data frame is an aggregation of, tell me, series, different series. For instance, this is an aggregation of the 3 series. And now we have even more. It was first we had, so we can split out. So the easy way, I think I already wrote. So now let's do the thing. I think it's already create this one, or I have to call the name pandas practice. You don't have to give it a name, and import pandas as PD. Great, this is how you do. And then maybe I may use the example from 30 days of Python, because the example is just awesome. For instance, just let me take this and show you what is this extra we don't need, and we are done with this, and let's close, and we don't need extra and get confused. What is this, guys? What do you see here? Tell me fast.
A list.
A list. Yeah. So now let's create, I want to use the same name. As you can see, since it is a series, I used S to make sense, you know, what we do. And then PD dot series, and just drop this nums. And then now print the series. Okay, so index were added. As you can see, it has index. I think even we can get the index, actually, index. Yeah, it has index, which starts from 0 and stops at 5 and by 1, but it doesn't include the last. So as you can see, yeah, it has index. And sometimes to see what it has there, just, yeah, there is good to know what's happening there, you know, the methods to see. For instance, I use the index, but there might be other, yeah, index. Yeah, great. Okay, let's see the you can do is just drop like this, or you can actually change the index. Now the thing is, actually I will show you by implementing this. As you can see, if you don't pass any index, the index starts from 0 and it will be, but if I want it to be started from 1, print s.index. As you can see now, the index actually is from 1 to 5. Yeah, even you can change. Let's see, my index wants to be like, if you want it, you can give it some kind of a weird index, and still it takes. Have you seen the index? We managed to give it an index. Great. So that is how it looks. And so it's not only for numbers. For instance, we have fruits, and then we change it to series, and the index we gave it is 1 to 3, because it makes sense, right? 1, this is what you get. And then dictionary. If you have a dictionary, something like this, and then again, let's create up from a dictionary. So again, S, pd.series, and then let me just drop this dictionary. So as you can see, very simple dictionary. As you can see, name, country, and city, and then just drop it here. But during, as you can see now, it has a kind of it's already has an index. So let's see s.index. Have you seen? The key became already an index, the key. But I think we can override also that if we want. Creating a constant panda series. For instance, maybe like if you want to create all 10, and then if you give 3, so you are about to create 3 values. And then you remember line space, right? This line space, so you know what it means. And then you can create as many numbers as possible. So now you understand what series means. It's the big concept, guys. It's very important, even though now it seems so, yeah, but I think you got what it means, because this awesome series actually are easy to understand. Then you merge this one, name, country, city, and it become a table. They were first series. They connect together, they become data frame, a big data frame. Yes, and then you saw how to make them data frame. Now I will show you this. Just let's copy this code because writing is taking us too much time. So that's why I am copying, but don't be a copycat so you don't learn faster. So now, as you can see, this is, what is this? What kind of data type do you see here? Guys, tell me.
Dictionary?
Yes, no, it's not dictionary. It's not. It's a list, guys. A list of lists. You have a list, a big list. I mean, inside that, someone, as you can see, this is the row for, I mean, for David and for John. Yeah, so it's list of lists, and then you drop this, and then columns. You give a column. Names will be this column side, country this, and city this. They're actually what I'm trying to do. First, I made this manually using some Excel kind of things. And then what I'm trying to show here is actually how the code looks like. Yeah, let's change it. Have you seen? This is what we see in the example. Yeah. But of course, you don't give it color here. No color. And you see the index. Great. Can we get the columns out again? Yes, def.columns. Have you seen the columns? Yeah. Can we just take out the names? Yeah, def.names. Oh, it was capital. Yeah, we saw this is actually one. What is the type this? This is series. This is series. This is series. That means the column only is the series. Okay, so I think you got the idea what it means. After this, it's all about reading data. So let's read data. Okay, great. Thank you. So let's read data. I stored data here, and the data I stored is here maybe. Data sets, and it's related to flowers. There are this iris flower. Let me show you the iris flower. Okay. This kind of flowers divided into, is that 3 or 4? Let me see from the data, Setosa and versicolor and virginica. I think it's into 3 categories. Yeah. So they look alike, but actually they are a bit different. And the scientists studied about the widths of the petal. Petal means this, and the length of the petal. And yeah, so we have data of this. And the reason why I brought this data, because in data science, machine learning, data analysis, this data is actually a very common data and a well-studied data. This is a well-studied data. Okay, that's why. So it's good to use standard data. So now let's read that. So to read PD, read. Yeah, by the way, you just write PD. PD means this, the panda, and then you look for dot and then press tab. And then you can see the available methods. I go for reading CSV because I'm about to read the CSV. And then where is it? Actually, I have to go to the data set, and then the name is Iris. Yeah, no, undo that. Yes, I managed to read it, so easy, but I want to store it as DF. DF means data frame. So if you just write DF, oh, it just gives you, this is how you read CSV. And if it was JSON, you just change it to this JSON. And then as you can see, we have 150 rows down from 0 to 149. And how many columns? 5 columns. 1, 2, 3, 4, 5. Okay, so if you want to see the first 5, you can say head, and it just shows you the first 5. You can also go up to maybe 25, up to 25. Even you can go further, but most of the time you just see the first 5 and maybe the last 5. Tell of something, you know, the tail of the panda or the data frame, just like the last 5. Okay, that's great. And then, for instance, if you're interested for the columns, df dot columns, yeah, this is how it looks like. And maybe if you are interested to only the sepal length, so sepal length, you can store it like this and data frame, and then sepal length. Now this value is actually the sepal length. Have you seen? How about if we want to just know descriptive df.describe? It's so powerful. Describe means now this panda goes through all the data through this 150 observation and gave me how many observation do we have? 150. And the mean. Yeah, the mean is actually how much? For the sepal, for the sepal length, sepal widths, and petal lengths and petal widths. So we get standard deviation, mean, maximum, and percentile we got just using this. And also if there is a missing data or not, actually we can use def dot info. This will give you just a kind of a summary. 150, that means, so from 150 entries, all are 150. That means there is no missing data. Or maybe we can actually do df not null, not null. Okay, sometimes. Is null, actually. Yeah, is null. As you can see, false, false means not null. So if this count, you can actually count the lengths like this. 150, all are actually, so that means there is no null. But it's not null, what's this not null? Not. Yeah, not now, I think. Oh, I have to check. Data frame. Not now. Yeah, yes, 10, not now. Yes, now. Okay. Not null. Yeah, so not null is 150. Yeah, that's good. So this is a very good. That means no missing data. So whenever you have a missing data, you have to remove it, or you have to have some way of filling that data. Okay. I don't want my students to live step by step, one after another, but today is the last day, so I want you to stay a bit, maybe 5 minutes, and yeah, can we do some mean or visualization using this? Yeah, we can do quite a lot of things with what is this, pandas. You can do almost anything with panda. Maybe I think almost even what the Numpy does, and even it has visualization by itself. But now what we saw is just the very basic one. For instance, if I want to group df dot group by group, let's group them by species. Why df group by, I think I forgot the by. So after this actually, and then maybe we need to count, value count, method. Oh, maybe I can just check the mean of all that. Yeah, after we group them, actually we can calculate the mean. So as you can see, now we group them. We have this iris and iris versi color, virginica. So now what we got here is actually their mean, the mean value. Of course, you can change this, the standard deviation and other values. Such kind of things actually take time to just understand, and yeah, first you have to understand what kind of data type are you working on. You have to have a domain knowledge of the data. For instance, I put here a very easy data type. I think this makes sense. Gender, height, and weight. This is so easy to understand and to deal with. So maybe you can go with this data because it's so easy to deal with, but I think I can't go further than this. Maybe I think what I promised to show you this another the package, that is the text blob, import text from text blob, import text blob. Yeah, this blob actually, I will show you text blob. It's a natural language processing, so easy tool. So go step by step. If you want to learn natural language processing, it's so easy. You can just, for instance, I can copy this code and paste here. Why cannot import name text blob? Okay, I will check what's wrong with that. Text.
There's one text block. There's an extra B.
Yes, triple string. I forgot to bring that. Cannot import name text. What do I write? Something like that. Yes, as you can see now, yeah, so after that, this is really very helpful. Then what you should do actually is blob and then text blob, and you put the text here. And then just to experiment, what does the blob has now? Oh, your text. Or can we get the words? Blob dot words. Yeah, it changed to words. Oh, really? Then blob dot sentences, actually. Yeah, all the sentences. Even you may look through for sentences in blob dot sentences. And print the sentences. Yeah, so line by line, I managed to print out. Even you can do sentiment analysis on this. Actually, how? Maybe you can say sentiment. Sentiment. Yeah, as you can see, have you seen this polarity? Polarity means actually the polarity. So polarity goes from, so let's see before I, between -1 and 1. So this means actually negative, it's the negative sentiment. Your customer is not happy about the product. So we can do a sentiment analysis tool. As you can see, it's the sentiment analysis, and also spell checker I have seen somewhere. So we don't have much time, but it would have been much. And maybe I can show you, I have some tool which I have implemented using this. If it's still working, I will just show you if it runs. Okay, so polarity, so this 0.6, so I think I would say this is not good, but this one is actually very good. No, very negative, it's negative. So let me just show you this. This is something which I have developed at some point to do some analysis. Let's just give it some time because it's deployed on a free service and it will load after some time. Okay, what else can you do? Because this is so easy to do. Noun phrase. Noun phrase is noun phrase, and then you just check blob noun phrases. Just give it time. So actually, it says that these are noun phrases, potential consequences. Like it, for me, this sounds like collocation, right? Collocation is something. Yeah, we'll need to leave now. Yeah. Okay. Yeah. Thank you. So I think I have to also end, guys. I prefer to teach you maybe in another extra class than also holding you here for so long. Guys, thank you so much. I think after this, you have all the power to use Python and to go further and use packages and to solve real world problems. Okay, it's not just learning the feature of Python. Instead, start using Python. And maybe also you can consider the Python, the data analysis with Python in summer or autumn. So I think I have to stop the recording.